All right, Yahoos, we're back with standard form of linear equations. Hopefully, we walked through this one a little bit. I'm going to show you two more examples of standard form, like how the equations work, and then we'll look at the specifics and shortcuts. But I want you to sort of have a conceptual understanding first. So, you're determined to make a lap of the Zugersee on foot, so you're going all the way down and around, and that's 40 kilometers, right? It's 40 kilometers around. You can run at 8 kilometers an hour, and you can walk at 5 kilometers an hour, and that's sort of the stipulations we're starting. And you can walk some of it. You could walk some, and then run the rest, or you can run all of it, or you can walk all of it, right? Some combination. So that's kind of what we're thinking. If you run faster, you'll do this in fewer hours, and if you walk slower, you'll do it in more hours. All right? Okay, so we're going to talk about this as x, the fast walking as x, and this is the number of hours it'll take you walking, right? And this y is the number of hours it'll take you running if you're going this 40K. So if you can run all the way around the lake, how long will it take you? Well, it should, that 40 kilometers, if you're going 8 kilometers an hour, it should take you 5 hours. I'm kind of zooming through these kind of quick. So if you don't walk at all, right, these are the hours you walk. If you walk none of it and only run, it'll take you 5 hours, right? So this is zero running hours, sorry, 0 walking hours, and 5 running hours. If you walk the whole way, that 40 kilometers divided by 5 kilometers an hour should take you 8 hours, right? If you're not sure about these, think about this. If you're going 8 kilometers in 1 hour, right? How long in 5 hours, right? In 5 hours, you're each one of these hours, you're going 8 kilometers. So you'd be going, in 5 hours, you'd be going 5 times 8 to get that 40, right? So we're dividing. You're dividing this side by 8 and this side by 8 to get that 5. So if you only run, it takes you 5 hours. If you only walk, it takes you 8 hours, right? Because you're going slow. So this is 8 walking hours and no running hours. And if you're doing a combination thereof, it should be somewhere on this line. So one combination that works is if you run, let's see, I guess we're yellow. If you're running for 2.5 hours, right, at 8 kilometers an hour, that should get you at 20. This will get you 20K. This will get you halfway around. And so then you're left with this other piece, which is if you take the 5 hours, if you're going 5 and you need to go the other 20 kilometers around, right, because we're going 40, that should take you 4 hours, right? So another way, another combination is 4 of the walking hours, right? That'll get you 20K, and then 2.5 of the running hours, and that'll get you, so this is 4 comma 2.5. That'll also work for you. And you'll notice that this is also on a fancy line, right? Let's make it blue again. This is on our fancy line, and there we have it. We're going to take that same idea and do this one more time with tiny trains so you can see the pattern. If you think you can see the pattern, you're welcome to fast forward. You might have to jump back to see this, but so this is the same idea with the tiny trains. Like at the zoo, maybe you have some adults and kids riding the trains. The kids take up 1 seat and the adults take up 2 seats, right? Because they have bigger backsides. So there are 20 kid-sized seats. So what's the largest number of kids the train can have? Well, there's 20 kid-sized seats, so there can be 20 kids. So this is the number of kids that can ride, And so you could have all kids, and no adults. Or if there's no kids around or the adults are running around instead, you could have 10 adults and no kids and 10 adults. That's another setup because each of these, there's 10 adults, each one takes up 2 seats, so you'd have 20 seats filled. So this is no kids and 20 adults. And you can also have a mix, right? You could have, let's see, well, you could have maybe 15 and, could you have 15 and maybe 10 and 10? Would 10 and 10 work? If you had 10 adults, oh, no, can't have 10 and 10. I guess you'd have 10 and 5. 10 and 5 would work because this is the number of kids and this is the adults. So you could have 10 kids and 5 adults. The kids take up 1 seat each and the adults take up 2 seats. So really you have 10 filled by the kids and 10 seats filled by the adults. So in total you have 20. So this point, 10 comma 5 would also work, right? 10 kids, 5 adults. And you'll notice, surprise, surprise, also on a big fancy line that hits all those points, right? And what this really means is that this point would work. You could also have, what is that, 8 kids and 6 adults, right? That point works. Also, this point works. You could have 16 kids and 2 adults, right? Because 16 are filled here, and then this would be 4 more seats filled because each adult takes 2. So this one works. And every dot along here works as well, provided that they're integer numbers. If you take all those and look at them like this, right? These are the equations. This was the first one. This is the around the lake. This is the seats. These are the lines and the equations thereof. So this was 20, comma 0 and 0, comma 10, right? Those were the interesting spots, the 0 points. This is the standard equation for it, right? This is the distance around the lake, or the time around the lake. And this was 8 and 5, right? This was 8, comma 0 and 0, comma 5. And the first one was the chocolate guys versus the yellow gummies and how many you could get. What I'd like you to do is look at these equations. I just threw the equations in for you. But what I want you to be able to do is take the equation and build me the graph by finding these 2 points of interest, right? So I want you to be able to look at this and check out this point, know where this point and this point are, just by sort of manipulating the equation a little bit. Take a second and think about how that will happen, and I'll pop me back on in a second and I'll describe that to you. Go. All right, so if you take a look at all of these points, let's look at this equation. If we're really trying to find the intercepts, these intercepts are this is the y-intercept because the line intercepts the y-axis. This point was called 0, 3, comma 3. This is an x value and this is a y value. And you can find this quickly by taking the x value and plugging in 0 for that, because we know wherever this line hits the y-intercept, the coordinate is going to be 0, comma something, right? This point will be 0, comma 1. This point will be 0, comma 2. We don't really know where this line is going to hit just by looking at the equation, but we know that when it hits this, the x value of that point is going to be 0. So let's plug in 0 for this. So now this is 2 times 0 plus 4 times, I don't know why. Equals 12. 2 times 0 is 0. This is 4y equals 12. And so y should be 3. Oh, lo and behold, look, 3. If we do the same thing for the x value, right? If you look at this, all of these points are 2 comma 0, right? 4 comma 0, 5 comma 0, 6 comma 0. You'll notice that this is the x, which changes, this is the y. This is the x that changes, this is the y. Everywhere on this line, the y value is 0. So if we plug in, I don't know exactly where this line is going to hit the x-axis, but I know that y is going to be 0 in that case. So I'm going to go back to this equation and substitute in 0 for the y. And so now we're going to get 2x, I don't know what x is, plus 4 times 0 equals 12. Well, 4 times 0 is 0, so this is 2x equals 12. And you divide by 2, and x is 6. Oh, hey, look, just like we thought, 6. Right? And so by looking at this equation, we can substitute in 0 for x and figure out, if we sort of negate this, now we have 4y equals 12, solve for y. And that's our y-intercept, right? And do the same thing for the x, substitute in y, and solve for x, it's 6. And we can plot those 2 points. Boom, boom. Let's try that here. Right? I know that I want to find where this line hits the x and y axis. Provided I wasn't seeing this graph, I would know that wherever it hits is going to be 0 over and some distance up for y. And we want to solve for that y, so we plug in 0 for the x. So this is 5 times 0 is 0, and you're just left with 8y equals 40. Divide by 8, and you get 5 as your y value. And so you plot that point. You do the same thing with the y value. I know that anywhere along here, these points are some value for x, 2, 3, 4, 5, 6, but 0 for y. They're not up off the x-axis. So the y value, you're going to plug in 0 for the y value, which effectively makes this 0. 8 times 0 is 0. You're left with 5x is 40. You divide by 5, and you get x is 8. And so you plot that point, right? And then you draw your line. Same thing here, right? Let x be 0. So the y value should be 20 divided by 2, should be 10. There it is. Let the y value be 0. So put in 0 for this. 2 times 0 is 0, and so the x should be 20. And draw your line. Okay, so we're going to take that whole understanding and try to do that with A. That's the whole goal, is to look at this and find the 2 intercepts and draw your line. Try that with A. If you're champion, try it with B. You might have to change B around so it looks like this equation. Pause me and I'll be right with you. Okay, so I know that this is a line that looks like, I don't know, this maybe. Wherever it hits here is the y-intercept. It is 0 for x and something for y, right? So to find this point, I'm going to plug the 0. This was the x value. It's none over, right? So we're going to put in 0 into the x and solve for y. So it's going to look like this. 3y minus 2 times 0 equals negative 12. Well, 3y times this minus, this is 2 times 0 is 0, so this becomes negative 12. So divide by 3, so y should be negative 4. Right? So 1, 2, 3, negative 4. That's the y-intercept. We're going to play the same game with the x-intercept. Wherever this hits the x, I know it goes through here. Wherever it goes through the x-intercept, this point is going to be some distance out for x, but 0 for y. I don't know what this is, but I can plug in 0 into this y value. So we're going to try that here. So we're going to do this whole thing again. 3 times 0 minus 2x equals negative 12. Well, 3 times 0 is 0, and 0 minus 2x is negative 2x equals negative 12. Divide by negative 2, x is 6. And so this should go through the x at 1, 2, 3, 4, 5, 6, if I did that right. And then this, there's your line, and it's graphed, and it's done. That's the whole game. If you tried this one, you can switch things around as well. And so this will turn into a standard form equation, and the 0, it should turn into this standard form equation if you're careful with it, and then these are your intercept points. Try those. If you can do this, you're golden. Cool. Try those out, and we'll work on some of these practice problems next time I see you. Cool. Bye.